All right, I wanted to take some bills that I got from a friend of mine, David Daher, and uh, just show an example of disaggregating energy use, turning it into load. We're just going to go through step by step. So their bills kind of suck. This is Excel here. And let's come on up here. And these charts suck. Your monthly electricity usage. There's no freaking scale. So unfortunately, you have to build a spreadsheet if this is the case, which stinks. So I went through month by month, and this is combined gas and electric. So there's 984 kilowatt hours and 10 therms. You want to see when the billing date is. So it's mid-September to mid-October. So I just called this October. And you can take a look at your average temperatures here. A lot of bills will have those. Let's scroll up to midwinter. Because this is Minneapolis and it's cold. So, here we are last year, 22, this year, 14. And that's for basically Christmas to mid-January. Typically, mid-January to mid-February is the coldest period in the north. And so here we are. Check out this. This is average temperatures, 9 and 13. It's freaking cold there. So this is a really difficult climate to electrify in. Now, David's house is new. So here it is. 5 bedrooms, 4 baths. It's interesting. I have conflicting square footages. So this is what the county says is 3,300. I suspect it's because some of the basement is counted. Because over here on Realtor.com it shows 4547, and I know there's a nice basement and a nice workout room down there. So anyway. So what I went through is I went and pulled all of these. So this is quite low usage for a large house in a cold climate, 254 therms for the coldest month. That's not a big deal. And apologies, I'm on the tail end of a cold. And so I loaded all these into a spreadsheet. So here's the monthly electricity usage. And then here is the monthly gas usage. So you can see January and February were the two highest months, and it's pretty much cold as balls. That is a really tough climate. Minneapolis is the toughest city in the U.S. in my opinion because it's large and it's bordering on climate zone 7, so it's really quite cold. There's Fargo, North Dakota is mildly colder, but this is a big city that's cold. The only other really difficult one is Winnipeg in Canada, which is basically due north. So looking at the usage here, I'm going to zoom in on this. So look at electricity usage. You can see through the summer it's moderately elevated to 1,800, 1,900 kilowatt hours, and the low months are between 1,000 and 1,200. So that means baseload usage is 1,100-ish, 1,200-ish, something like that. And then the difference aside from that is going to be cooling in the summertime. And in the winter, it's probably lighting, or it might be increased water heater usage because the water coming in is colder. So David's house has a heat pump water heater, and you can see that because look, his therm usage is super low here. So he's got a bunch of kids. I think it's 5 little boys, and so this would be much higher if there was gas water heater usage. So the furnace is basically the only gas burning appliance that's left. So he asked, hey, can I potentially move to a heat pump? And so that's what I wanted to try and figure out. So his annual usage is 1,200 therms, which is, that's a good chunk. If this was a milder climate, I'd be like, whoa, what's going on here? But his house is quite tight. It was what was it, a 1.5 or a 2 ACH50, so it's probably 1,000, 1,500 blower door, which for a house that size is really not bad. This right here, because we know that the only thing that is gas is the furnace, we know that this 1191 therms is all heating. If you had water heat, say there was 10 therms a month of water heat, you'd subtract 120 from this, so 10 times 120. So generally your water heat's going to be between 10 and 20 therms per month, unless you have a really big family or something's really screwed up. Okay, so now that we have our usage, and actually, you know what, I'll do one more. So cooling. So we're going to add up. Here's our cooling once. And then we're going to subtract. So I said 1200. 1200 times 4. So cooling is 2300. So now we have our cooling usage and our annual heating usage. So these are what we're going to use. And I mean, this is pretty minimal. I mean, 2,300, it costs $300 to cool the house for the year, you know, give or take. That's like 15 cents a kilowatt hour. So not a big deal. Okay, so let's go load this house into here. Let's see, I need to check what is the zip code again. 55042. So here is carrier's thing. So you want to start with 55042, put in the zip, and then we're going to simplify gas to $1 a therm and electric to 10 cents so that what it shows for usage is the same. So base system, he has an AC and gas furnace. And I don't know, we're going to call it a SEER 13 for AC. I don't think it might have been a 2-stage or something like that. I guess we could go, well, it's funny, I don't know the mid-range models. Yeah, we'll just stick with, we'll make it a SEER 14, whatever. It's not going to, cooling, we're going to move like $50 a year. It's not going to matter. And then it's a pretty good furnace. So we'll call it as efficient as it can be. So we'll be as nice as we can. This will push load up and will make the numbers look worse, if anything, because this is a 98% furnace. And so let's see here. Total fuel cost. So at 50,000 heat load, he's at 1,013, and what we're trying to get to 1,200. So it's going to be more like 60,000. Now keep in mind, this is a very low design temperature. So this is a design temperature that's below 0 Fahrenheit, which is not super common. And so let's see, and cooling is 23. So his cooling is actually less than this. Cooling is 219. And that's pretty close. So we want this to be $233. If this isn't totally dead on, but it's going to be close. So his cooling is going to be slightly higher. Let it recalculate. 256. All right, so 40,000. So you see, I'm just walking these into where I want them to be, and we're at 1,200 therms here because I'm looking at total fuel cost 1,200 and cooling cost 240, and this is again at 10 cents a kilowatt hour, so that's 2,400 kilowatt hours and 1,200 therms, and we are at 2,300 and change and 1,200 therms, so close enough for government work. Again, once you get within a half a size, who cares? You know, if you're within 6,000 BTUs, it's fine. Okay, so now what we want to do, he wanted to understand what is it going to take to put this to be heat pump only. So I'm going to run a hybrid, and then we'll run 2 heat pumps. Actually, we'll probably just run 1 heat pump because this climate needs top of the line. So we'll do hybrid. And like I said, the VNA4, I don't know if they programmed the numbers in different, but its performance is basically the same as the VNA8, which is the 5-stage, which is something's, I don't know what's up, but something's not right, because the VNA0 and the VNA4 should be very similar performance. And we'll give it an MN7 furnace. And here, actually, we'll do 2 hybrids because we can show what happens when we lean on it different ways. Hybrid, VNA0, MN7, and then I'm going to check this because that is, leans on it for heating. So, oh, it's interesting though. Usually you see it choose a different piece of equipment between here, and it's not. Thermal balance points. So at these prices, economic balance point is you switch to the furnace below 23. Thermal balance point, it is hanging on until minus 12. And these shouldn't be different because it's the same piece of equipment. Go figure. This is not a perfect calculator. It's pretty good. And then let's try heat pump only, and we'll give it a VNA 0. And remember to check this for heating. And it's curious, it's not choosing, it should be choosing the 5-ton to do that, and it's not. So this is not perfect. And basically, because this already has a really good furnace and the majority of costs are heating, this is showing, again, this is $1 a therm and 10 cents a kilowatt hour, which is not reality. We're seeing very minimal annual savings. And interestingly, the heat pump shows being less with this particular split. You can move your fuel costs around and you're going to find different things. So I'm going to screenshot this for him. And then let's change this to something more realistic. So I think it's going to be, we'll call it $1.30 for this year. It's going to be more, and 16 cents. So see, our savings numbers moved around. And that's interesting. So a hybrid in this case is actually, it shows negative savings, but the heat pump is still showing the best. So that's interesting because this does pull from this calculator looks at hourly usage for whatever climate zone you select or whatever zip code it goes, and it pulls the nearest airport, and it's fairly flat there. So I would imagine that the airport will have similar weather. Sometimes if you're in a mountainous region like where I live, like I don't necessarily want to pull Charleston, West Virginia's airport data because it's actually a climate zone warmer than where I am here. Even though I'm south, it's not right. So you want to choose the airport that's as close as you can. This doesn't let you see that. It does it automatically. But anyway, so I ran this at I think what are realistic numbers, and it's within $200 a year. If his gas meter fee is $15 a month, that would be a break even as far as operating costs goes. And this isn't showing what the resistance usage would be, but it wouldn't surprise me. Like one thing that I suggested to him is rather than having resistance backup, because he's an HVAC contractor, put in a mini split as part of your backup heat, or consider doing so. Like you could not do it the first winter, and if resistance is a problem, you could do that as a backup. Like wouldn't make sense as a customer to spend $5,000 for backup, but as a contractor, you know, it's not that much work to do if you so choose. So it's just an option. Okay, so we're coming up with a 5-ton load and a little over 3-ton cooling. So let's go look at Auditor, And auditor pulled 3,309 square feet, which is what Zillow says. So this is pulling from county records somewhere. And like right now it's showing an open field. So who knows which way it is. Let's see. So here is the house. So it largely faces that way. So we're going to call south is the, you have to choose which direction has the most glass, and we're going to call it south. It could be south or southwest, but whatever, it's fine. It shows whatever glass you show as the dominant. You'll see south and north have quite a bit. West and east probably have a marginally more than this, so let's just change these to 80 because it's a good sized house. Shading is going to be none right now. Can we change to this? Yeah, so there's no shading at all. So we're going to change that to 0. 2019. Good. And so exposure diversity, this is showing what your glass is going to do because it's south facing, and we can change this around. So so what we're coming up at 45,000 here. Let's click west just for giggles. There, see how the shape changed, and it's still also about 45,000. So we're going to change this back to south, and 80 and 80. And it will think its way through it. And look, it is showing quite high heat loads. So it's 124,000. And again, I'm going to screenshot this. So this is where we're starting with what it assumes. And we just, through Carrier, found that heating is actually about half that. Now, the tight, well-insulated new home. So keep that in mind. But this is interesting to me because I haven't seen actual data on a house this far north. And yeah, showing 714 for heating. Now let's see, natural gas rights. We're going to again start by simplifying this because we're going to true to this. And yeah, here we go. 62,000 cooling, 124 heating. And from looking at the actual energy bills, we know that it's way less than that. So it's half this, and it's 2/3 of that. And so we can tell by annual costs that we're definitely not there, because we can look over here at annual costs. So heating cost should be 1,900-ish, or heck, it's 1,650 here. Expensive electricity makes math not as good. Okay, so let's go. Oh, this is new. I haven't run a load in a short while. This was called like audit before, because you put in what the area of the thing is. Oh, here we go. Ceiling R value. I'm going to assume he went all out and it's 60. So it's interesting that the assumptions are this low. We're going to call it R20 for the walls. And Energy Star windows are R3, which is about that. Solar heat gain in this climate doesn't really matter. Sounds fine. Yeah, look, design -11. That is a cold climate. Number of residents, 6 and 6. Floor over unconditioned basement. Yeah, it's the basement really throws off loads, so we're not going to worry about it. But basements don't add a lot of load. You just have your 2 feet that's above grade. Everything else is below grade and somewhat protected. It's not going to see the extreme temperatures of the climate. R value basement walls. That's, most basements are well below. We're just going to call it that. Duct losses, fine, 10%. I don't know if he has ventilation, so we're going to call it a 50. And I forget what the exact blower door is, but it's quite low, so we'll call it 1200. It might be 900 or something like that, but this is close enough to give us an idea. Here's home energy modeling. So when it was 1200, okay, we have to, this is probably this is 11,000 kilowatt hours a year, which is probably somewhere in the ballpark, not knowing exactly what water heat is. And here we go. We'll call that 95. And we're just going to model him with a straight heat pump. And I'm going to give him a green speed, so 13, 21. And he has heat pump water heater. They're about 350%. Oh, that's interesting. Okay, so yeah, they split this up different. It used to have R values and stuff in here. So this is looking better. That's nice to see. Now look, this moved around. Oh, that's funny. It actually, well, what are you doing? Hold still. Huh. It really shouldn't be that big of a difference. That's probably from where the energy costs are entered in. Yeah, water heating replacement, why 575? They're the same. Yeah, so I don't know what's going on there. Well, let's go see if we can get the load to be in the ballpark. So this is where you want to have a double check for this program. Okay, well, we went from 120 down to 72, so that's good. And so cooling, we want this to be 230 at 10 cents, and heating, we want this to be $1,200 at $1 per therm. So we're going to move these down. So heating costs will go 25% lower. Cooling costs, yeah, so there's $1,200. A little bit lower. Cooling costs will come down about a quarter as well. There we are. Oop, cooling, that's a little bit too much. So again, we are going to 2,300 for cooling, 1,200 for heating. That's what we're looking to do. So there's 220. But it's good, these loads look like they are coming close to checking out because we, in Carrier, came up with 40,000 cooling, 60 heating. And here we're seeing 41 cooling and 52 heating. And $150 a year for water heat. So these check out. There we go. Yeah, so 52,000. Heating 41, cooling. So it's interesting for such an extreme climate that these are so similar. So, and you will find the tighter the house, the closer heating and cooling get to each other. Because like you oftentimes don't need heating until say 55 or 60 degrees because the internal heat gains will be enough to keep the house warm. That between that and some solar load. And I think it's fairly sunny there. But okay, so let's see what it's suggesting. So right now, with those energy costs, it's showing a slight savings, but that isn't quite it. So here, I better screenshot this again. So let's change to the same assumptions I put here, which is $1.30 a therm and 16 cents. 3, 16. And then let's see how this calculator's going. So it's still showing mild cost savings. So that's interesting. And that was, again, that's a green speed. So I mean, this is absolute top of the line equipment that you're going to be looking at. So there we go. And don't trust these entirely. I don't trust them entirely. Well, like cooling system replacement, $195 a year. It was only costing like $300. So that's a pretty big move. I don't know that it's going to be that big of a move, but what you're looking for is cost parity. So like here, you're within $200 a year, and that's with current prices. I don't think natural gas prices are going down. They're probably only going to go up. We're getting more and more connected to world gas prices, which are way higher than what we've been used to. I mean, world gas prices are typically anywhere, 3 at the bottom end, 3 times what we're paying, and as much as 20 times more than what we're paying. So the days of cheap natural gas are gone. It's going to be much closer to oil or propane. But there we are. So it started from bills, 1411, 254 here, put that into all of this, and then we backed into, well, so all of this, and then we figured out what the cooling usage is, the heating usage is, and then backed into Carrier, and then checked EDS, because I definitely don't trust EDS all the time. So if these two say something really similar, you're probably close, because they're both taking energy use into account. This one also takes blower door into account. And then you could also use this, say you were going to improve the shell of this house, which, like, this house doesn't need anything shell-wise, it's fine. But if you're going to improve the shell, you could run 2 models in this. So you could take the house with existing HVAC and improve the shell, see what happens, and then you could take the house, improve the shell and the HVAC, and see what happens. So it's a good way to learn. So I hope that was helpful. It's another example. This is a very cold climate, and it looks like heat pump's going to be just fine on this 4,500 square foot house in Minneapolis. So pretty cool to see. Talk to you next time. Bye.